One is a graph showing the trajectory of a rugby ball. The height is plotted against the horizontal distance. It travels in a vertical plane. That just means it travels like in a two-dimensional plane. It's not like veering left to right, spinning to the left or the right either. So we're working in 2 dimensions. And we're asked to find a quadratic equation linking h with x that models the situation. I should just add, we're told that it reaches a maximum height of 12 and it hits the point of the ground of 40. Now, one thing you're expected to know in this question, that a quadratic has a line of symmetry going down from the turning point, and this splits it entirely into two, which means that the maximum is found at 20. Now, I'm actually going to go through part A in 3 different ways. There is a quickest way and there's a less quick way, but it all depends on what information you have as to which way is going to be the best in general. So I just want to make you aware, and you can't just necessarily rely on just one of the methods. So method number one, we actually have the roots of the quadratic. So we can say the one root is 0, so we've got x, and one root is 40, so we've got x minus 40. The only thing is that there's lots of quadratics with even like a positive one like this with those roots. So we just need to times by a little constant to get the right scaling. And we know, see, we've got this extra point, 20, 12 that it goes through. So when h is 12, x is 20, we can say that 12 is a times 20 times minus 20. Because you can see this is going to be a negative quadratic. All right, so what we can do is do 12 divided by minus 400. Give us minus 3. I'll write it as minus 0.03. So h is minus 0.03 x minus 40. In method 2, sometimes you might not be given the roots, but you might be given the maximum and maybe another point. And we can use the idea of completing the square. So because when you have, okay, let's say let me just give you an example. I'm asking you to complete the square on x squared plus 4x minus 7. This becomes x minus 2 squared minus 4 minus 7, so minus 11. And we get the maximum at 2 minus 11. I'm not going to go into lots of detail on that, except to say that this thing is always greater or equal to 0, so the thing overall is greater or equal to minus 11, and this will occur when x is 2. Now, if we have the maximum, we can therefore work our way back. It must be that we have x minus 20 squared plus 12, because that will get nearly, this is not quite it, but nearly, because that will give us our maximum of 2012. It has to be the case. The only thing we need to think about is that there could be a scaling factor here. So again, the a comes in. And now we just need a point to use. I could actually use 0, 0 or 40, 0. I think I'm going to use 40. Actually, it's going to be exactly the same. I just looked. So h is 0, and I'm going to get a times 20 squared or minus 20 squared. That's why it's actually going to be the same. Plus 12. And I'm again going to get a is minus 12 over 400, which will give me h equals minus 0.03 times x minus 20 squared plus 12. It's just this time it's in completed square form, but it is actually identical to the one on the right. So you might not really like that one. I think it's a little bit more subtle with this bit here, but you might be forced to go down that path. Okay, final method. It's not the best one here, but it does work in general, and it is to write h as a general quadratic. And then use the point. We actually have 3 points that it goes through. So because it goes through 0, 0, 0 is actually going to equal c, and that one's gone. And then we know um, height is 0 and x is 40. So 0 is going to be a times 40 squared. That's 1600 a plus 40b. Okay, I can't get anything from there, but I do have my other point. It just happens to be a turning point, but it doesn't have to be in this for this scenario. We just need 3 points. Whereas for the other ones, we actually needed 2 points because we had that maximum. But I've got 20 and 12. So 12 is equal to 400a plus 20b. I can double this one, so it's 24 equals 800a plus 40b. Got my other one, just rewrite it. Okay, to be honest, you could solve these on your calculator, the simultaneous equations, but I'm doing it here. I'm going to get minus 24 is 800a, and then we're going to get minus 24 over 800, which is going to be the same as minus 12 over 400, minus 0.03. Put that back in to get b. So 1600 times minus 0.03. That's minus 48. Add the 48 on. Do 48 divided by 40 to get b, which gets us 1.2. So h is minus 0.03 x squared plus 1.2x. And you could then, if you wanted to, factorize out the 0.03x and do 1.2 divided by minus 0.03. Which gets us back to minus 40. Okay, sorry, I was just doubting myself there, but that is exactly what we had up here again. Okay, I wouldn't advise you use this method here, but it is at least the most general. So I'd say if in any doubt, if you're just going to learn one, it's probably this one because actually I take that back because if you're only given 2 points, it won't work. But okay, what I would say is become familiar. If you're going to like master this topic, become familiar with all three of these methods so that you can find a quadratic from a graph. Told the ball passes over the horizontal bar of a set of rugby posts that's perpendicular to the path of the ball. The bar is 3 meters above the ground. Use your equation to find the greatest horizontal distance of the bar from O. So it's let's imagine it just goes over it, okay? Because obviously if it's like here, this is my little rugby post, it's going to go over it no problem. But we want it where it just goes over it. That is going to give us the largest horizontal distance. Of course, it's symmetrical, so it's also going to have we're going to have a solution to our quadratic over here, but we're going to be taking the larger one. So I'm going to take probably best to like expand it and take this one here. So this is part B. I can say that minus 0.03 x squared plus 1.2x. I'm just going to set it equal to 3. That will tell me the two positions where it is 3. I always like to make my x squared positive, so I'm going to add that term on, minus the 1.2x, add 3 equals 0, and we can use the quadratic formula. It's a modeling question. It doesn't say we can't use our calculator for whatever reason, so I definitely think just using the quadratic function is the best way to go. Of course, make sure you can do the minus b plus or minus 1. So 0.03 x squared minus 1.23. We get a third, but we get 37.320. We do get the second solution, 2.6794. So that one is going to refer to this bit here, whereas I actually want the largest distance. So it's going to be x uh, 37.3 meters. Finally, we're asked to give one limitation to the model. I would always throw in air resistance. I just think that's the simplest one to remember. So yeah, you can write that one down. Here's some others, because sometimes it will say other than air resistance, give a limitation, because it is such a it's probably one that everyone uses. So you could say, we've assumed the ground is horizontal. We've had to have that situation, whereas in reality it might not be. It's being kicked from the ground rather than like a drop kick or anything, or maybe raised up slightly. We're assuming it's exactly on the ground. It's modeled as a particle. It doesn't have like dimensions and things. That does have consequences. We've modeled the bar as a line. No wind or air resistance. No spin on the ball. That was that assumption about it remaining in a 2D plane. No obstacles, and we've assumed that it's a perfect parabola. Okay, so quite a few different things that you could write down, potentially others as well. But I'd say like the best thing to do is I would always like, especially for mechanics as well, remember air resistance and wind for this sort of situation, and then um, things like spin are good or particle, and then other things related to the problem are useful if you can't remember any of those, such as the ground being horizontal. Anyway, just practice those for these little one markers, and well done on this question.